I see the flying car industry as game-changing when it comes to not only future warfare, but future military operations. Just as important, humanitarian relief operations, hurricane support, all the things that we do defense of the homeland. If you start thinking about these devices as nodes in a network, it fundamentally changes the game.
Agility Prime is a program with a vision of world impact. By partnering today with stakeholders across industries and agencies, we can set up the United States for this aerospace phenomenon. Potential outcomes are rewarding and transformative with both military and commercial applications.
I want to offer my congratulations to Dr. Roper and his team for achieving this revolutionary rapid contracting and prototyping method to bring industry and DoD together to develop this new exciting technology with both military and civilian applications. This technology will have great benefit to the needs that we have in Alaska and the Arctic, where conventional aircraft, vehicles, and vessels oftentimes can't operate.
Agility Prime is part of our Defense Department's long history of turning futuristic ideas into reality. I'm proud that the federal government is investing in revolutionary ideas. Agility Prime is leading the way.
This launch of Agility Prime is so exciting. This technology has the potential to make vertical flight more affordable and more widely available. And with the encouragement of the U.S. Air Force and the entire federal government, American companies employing American workers can gain a head start and win a fair share of this lucrative market. eVTOLs have the same agile, vertical takeoff and landing capability as helicopters, but are quieter and should cost much less to operate because of their electric motors.
We are becoming a trusted innovation partner in commercial tech. I could not be prouder of this initiative. I could not be prouder of this team. And I am excited to see how quickly we can go to help commercialize this market for our nation so that our warfighters have options they don't have today, and our nation has an economic advantage far into the future. Innovation is a battlefield, and Agility Prime is just one way we're going to win it.
Agility Prime seeks to ensure a global advantage in advanced logistics technology. Agility Prime can reduce the risk of adversarial commercial dominance resulting in military disadvantage. As the United States Air Force looks at generating combat power away from runways, those distributed logistics aircraft must be runway independent. This new transformative capability is a promising opportunity to conduct that mission in an affordable and a scalable manner.
Today, we gather for Agility Prime to drive transportation innovation, lower barriers to entry, and expand our partnerships.
We see a time when automation technologies make the requirements on the pilot much less. And we see flying as being accessible to a much wider range of people.
And it's truly a great credit to Agility Prime. They could put on this virtual event with so many hometowns of the United States represented. You know, industrial base is not really about just what a country can make. More than that, it's about the people who dream up what to make. And then, of course, those people who make it.
Good afternoon and welcome to our updated series that we're doing for Agility Prime as we look at a webinar series moving forward. It's been a little time since I've had the chance to attend the webinars. Last chance was back as we did the team up event back in the middle of July. And since then, wanted to give a brief update on some of the fantastic work that the team has been doing. And when I say team, I certainly mean our government team, but more importantly, the industry team that's out there actually, as the senator said, actually making these things fly. And that part of making things fly is what is extremely exciting for me today as we begin to take a walk through the ecosystem. And that ecosystem is that online place where those who are out there producing either creating services or producing hardware for this electric vertical takeoff and landing market can register. And if they like, in the future, join us as speakers as we're about to launch this tour through the ecosystem. But before we get into the introductions for the fantastic group that we have here this afternoon, I want to talk about a couple of things that have happened since we did our team up event. So we met there in July, middle of July. We opened up the small business technology transfer opportunity on the 10th of July. That closed on the 10th of August. And it was absolutely phenomenal. We received over 300 proposals for that STTR. And we are now feverishly working to go through those proposals with the intent of awarding contracts here within the next month, looking at what our end of year looks like. As we are closing that out and looking to see across the spectrum of technologies there, a phenomenal group, really across geographic locations, across different sub-disciplines, and really the engine that is going to drive this industry into the future. Yesterday, you might have seen, some of you, the launch between NASA and the Air Force, the work that we've done just over the last few months in starting to develop that ecosystem, starting to develop this initiative on the supply chain. The folks that are here today are a key part of that supply chain. That ecosystem is a key part of that supply chain. And so if you're looking at an opportunity to show those capabilities that you have to offer this exciting new industry, welcome you to go to agilityprime.com, look at ecosystem and register yourself there. Go take a look around at the other companies that are there. You can sort by multiple different metrics and see who's out there and see what type of collaboration might be there across a multitude of different industries, as well as like I said, services, research universities that are out there, state and local companies, state and local entities that are out there ready to move this industry forward. Since our time there at the Team Up event, one of the main items that we've had the opportunity to announce is our Air Force Airworthiness Office has identified a path and has given authorization for an approach to do certification. And we are specifically different than the FAA. We call it airworthiness, but it is the opportunity to be able to fly these orbs with a government certification and in a revenue generating use case. And so we're excited with several of the companies that are well on their way to achieving that, that flight release that allows them to begin to conduct a variety of different operational use cases that we've discussed previously on these series. You can see those at agilityprime.com in the events section, specifically on the different use cases. So we're excited to announce the fantastic work that's been done by the Air Force Mobility Command, the Air Force Lifecycle Management Center, there in that airworthiness office, the fantastic leadership that they've shown at looking at new and innovative ways to be able to bring these vehicles to the air. We're looking to do that very quickly with some of the contracts that have been awarded. We'll begin to talk through some of those contracts. We're hoping in the not so distant future, we'll actually be able to show the flights that these folks are doing. And so please stay tuned in as we begin to see this exciting development unfold. Along those lines, we've had the Air Race to Certification. As you know, that is one of the contractual manners for collaborating with the Agility Prime team. In that, so far, we've had 16 submissions for that Air Race. That's 16 companies out there that are planning to fly prior to 17 December 2020 this year. As many of you know, we are looking at options, what it looks like as we approach that date to potentially continue to keep this open. If you are not flying prior to that, that does not mean that you are out of the competition. We'll take a look here in the not so distant future, we opened that competition up into the future. We scaled it initially so that we could identify a bit our resourcing required, and have been really impressed with the phenomenal feedback. Of those companies, we have 4 of them who have advanced on to the phase 2 process, and actually already 3 of them who are now in the phase 3 stage, remembering that phase 3 is an opportunity where we provide the request for prototype proposal. That prototype proposal is then sent back to identify where are those areas that we actually would be able to start collaboration in the development, reduction of the technical risk in the vehicle development that's out there. So we have 3 companies on a path to do that, hoping to begin to announce some of those results soon, to be able to see the fantastic work that's happening eventually across our ranges, across our wind tunnels, and across a variety of different test assets that we have as we look to bring these vehicles into the air. Also, like for you to remember, for the small companies here in the fall, not so distant future, many of you saw the Small Business Technology Transfer Program that we released, and that is closed just at the beginning of the week. In the not so distant future, as you know, I have recently become the AFWERX director. Internal to AFWERX, we have the AFVentures team looking at new ways of taking the small business program and accelerating that small business program in conjunction with the SBIR Center of Excellence, and finding ways for new contractual opportunities in the small business program here in the fall. So definitely keep an eye out for those. But as you can see, good progress that is being made across the board. A lot of that progress is really a function of the fantastic work that's happening with the partners that are out there. Our NASA partners who are launching the supply chain effort yesterday, certainly the industrial partners. And so with that, I'm going to transition over to the panel that we have today, starting with our government folks that we have. We have Argonne National Lab, Dominic Karbowski, here to talk about aircraft system simulation, computational fluid dynamics. After that, we have Danielle Mclean from Happy Takeoff, looking at opportunities for hydrogen fuel cells and aircraft design. We've got Dr. Robert Yancey, the Director of Business Development for Hexel, and going to be talking about different composite materials. From there, we've got Larry Williams, President and CEO of Aviation Safety Resources. We have Tom Fury, CEO of Sagatech Avionics. And we've got Sean Herman, Vice President of Future Projects for Blue Force Technologies, looking at aerostructures, design, and supply. And then finally, we've got Chris Wallower, Sales Engineer of Persistent Systems, talking about network, data link, and communication. So you see kind of a spectrum of different capabilities that are out there. I'm excited to hear from our partners. All of these folks these are companies who have registered in the ecosystem. Look forward to other registrants out there. And with that, Sterling, over to you as we begin taking this tour through the ecosystem.
Yeah, for sure. I think we're going to start with Dominic. I just ask everyone if you have questions for the companies, put them in the Q&A feature as always, and we'll ask them at the end. Dominic, are you ready to present?
Yes. Good. Can you see the slides?
Yes, we got you, sir.
Okay. Good afternoon, everyone. I'm going to present the capabilities of Argonne National Laboratory, and in particular the Center for Transportation Research. So Argonne is a national laboratory that's operated for the Department of the Energy by University of Chicago. And we are a big campus with over 1,500 researchers. And we cover a wide array of topics: basic science, energy, global security, computing, artificial intelligence, batteries, so forth, so on. And within Argonne, the Center for Transportation Research, or CTR, has decades of experience in transportation energy efficiency research, traditionally more on the automotive side, but there's so many capabilities we developed that we recently have expanded to the aviation world. So I'm going to present a little bit some of the the tools that we develop at Argonne that can support aircraft design and aircraft design optimization. So two really aspects. One is CFD modeling. So we have developed computationally efficient 3D CFD capabilities. So we can, with these tools, we can compute the complex flow dynamics, we can compute aerodynamic coefficients, and we use high performance computing to do that. On the right-hand side, you have a brief overview of a tool for system simulation that we're developing called Aerodynamic. And that's to model the entire flight mission, and model the operation of each subsystem. So that's eventually a tool that's going to be released and licensable, and that allows to do parametric study and find the best trade-offs between energy consumption, endurance, range, and payload. So first, let me go a little bit deeper on aerodynamic. So here I present a little bit what the use case would be for end user. So first you start with defining your aircraft. So either from for a library of existing aircrafts, or from assembling the aircraft from subsystems, and all of this is fully customizable. So right now we have models for fixed wing and rotorcraft. Then you can define what mission you want to fly. Then, so this is a Simulink based model. So then the Simulink diagram is created. We run the simulation, and then we can analyze the results. In this case, for example, what is shown here is the operation of a fixed wing electric plane. So on the top, you have the battery power, motor power, and propeller power. And you can see also the efficiency on the bottom plot here. We also created models for rotorcraft. So in this case, it was a hexacopter. So as I mentioned, we model each of the subsystems. So for example, here we have 6 power plants corresponding to the 6 propeller and the 6 batteries. And we can model the entire flight. This is an example of a mission, a mock-up mission at Argonne, where we go from our cafeteria and deliver sandwiches around the campus. And the UAV flies with some gust winds as well. So we can predict the energy consumption, range, and things like that. The other topic of my presentation here is our CFD capabilities. So our CFD capabilities enables the analysis of the interactions between a UAV or an aircraft and its environment. So first, this is an example of a fixed-wing UAV. So it's a Pioneer. So it's a pretty old UAV, but for which we had some published data was available. So we use a code called Converge, and we run it on high-performance computing clusters. So that enables adaptive meshing. So there's more mesh cells around points of interest, and that enables to capture highly complex transient flow phenomena such as tip vortices. And one also very interesting aspect is that we can calculate aerodynamic coefficients, as you can see in the middle figures. And this is a comparison between the wind tunnel simulation that were published and our calculations that are just based on geometry. And we can use these aerodynamic coefficients to run our system simulation using Aerodynamic. We also develop models for rotorcraft. Again, this is for we're showing here for an aircraft for which data is available. So we can do similar simulations for individual propellers, as you see in the middle, where we can just look at the vorticity and predict the thrust, or at the entire aircraft level. So these two capabilities combined can help designers, the people who build aircrafts, maybe predict a little bit in the simulation what their aircrafts will do, and maybe find ways to optimize them. Thank you. And then just, I'm not sure if the presentation will be shared, but there are contact information, papers, and I think this information, a version of this presentation is also available on the Agility Prime website, on the Argonne page on the Agility Prime website.
Yeah, for sure. Thank you, sir. That's great. Just one question from me is, what is the best, can you just go over the pathways for folks to get involved or to use you guys for modeling work? Who can they reach out to? Is it require a government contract? Can they come in as a private equity?
No, so we're affiliated with the government, but we're not the government. So basically, it depends if it's your companies are participating in a call, then we can be a sub, so sub awardee, or in the case of more SBR and STTRs, we're just providing letters of intent, and then we establish a contract and a sponsored research, basically, so sponsored research partnerships. And outside of these, companies are welcome to also work with us and develop some. We can come into an agreement for a contract to perform work for these companies, and also sometimes we perform research without exchange of fund, but more with exchange of capabilities, often data, so we can find mutually beneficial research where maybe we develop new models that would benefit generally the overall community, but would also be of particular interest to a particular company or customized to the needs of particular company, for example.
Sure. Well, thank you for your time today. It was an informative presentation, and I appreciate you coming on. I think we're now going to switch over to Danielle Mclean from Happy Takeoff. If you could stop sharing, sir.
Thank you.
Danielle, thank you.
Thanks, Sterling. Can you see my slide?
Yeah, we got you.
Awesome. So I'm Danielle Mclean, CEO of Happy Takeoff, here with Rachel Locks.
Rachel Locks, COO of Happy Takeoff. Trying not to disappear here.
And so we'll kind of just walk through, go next slide, please. Kind of walk through a little bit of what Happy Takeoff does and let you hear from some of our team. So as I said, I'm Danielle. Rachel, Dominique is our CTO, Daryl Cummings, Jay, and actually it should be Dr. Jacob Jamie right there. We just didn't have time to update this slide. I'm not going to talk too much. Those of you who know me know I can blab forever. I want to give you guys a chance to hear from these rock stars. And I'm just going to breeze through this slide. We believe that the earth is the most important thing and that all humans are created equal. And that's pretty much the short version. And so we're going to skip through a lot of the slides while Rachel talks. I'll let her do that. This next group of slides can be found on our website. So if you want to look at them in a little more detail, feel free to go to happytakeoff.com. And with that, I give it to Rachel.
Hi, I'm just trying to make sure I'm not ghosting on the camera here. So at Happy Takeoff, we're very interested in hydrogen, and we're going to kind of flip through these slides pretty quick because we want to give our team members a little time to talk about our technologies and our vision. But this is kind of why we're interested in hydrogen. Lithium ion is terrific in certain use cases, but we see that the higher energy density of hydrogen fuel is going to enable things like longer flight time, quicker refueling times. And we think that will translate, the longer flight ranges will translate into a lower cost for implementation of infrastructure. So when we started looking at hydrogen, we kind of pursued this from the infrastructure perspective. There are several of our friends and other companies working on some awesome hydrogen fuel cell designs like Zero Avia, Alakai Sky, Bartini, just to name a few. So with the increased flight range you can get with that higher energy density of the hydrogen fuel cells, this slide represents kind of a conceptual scenario in the trip between San Francisco and Los Angeles. I'm sure most of you know that that's a pretty congested traffic nightmare, so of high interest to to urban air or to advanced air mobility. So if we have, for instance, a 60-mile flight range, that's represented on the left, and on the right, we have 250-mile flight range. So you can see not only fewer stops to refuel, but it covers much more of the coastline, and you also get Vegas, San Diego, and even Tijuana in the flight range. So it's kind of our vision is to implement captive use hydrogen, meaning we make it on site. And with that, I'd like to let Daryl Cummings talk a little bit. He's our lead aircraft designer. Daryl, are you with us?
We had trouble getting Daryl's audio working earlier, so Daryl, if you are here, feel free to cut in and interrupt me. But meanwhile, I'll just kind of go ahead and talk a little bit about PRISM. We are so very excited to introduce PRISM. As Rachel said, you know, we were kind of looking at infrastructure from the beginning, just trying to find what were the gaps, what needed to happen for eVTOL to proliferate everywhere. And we saw that infrastructure was a really big constraint, especially when we started talking to cities and states. They weren't really too keen on the idea of, you know, putting, you know, landing location every 10 miles or so. And so we were really putting our brains together trying to think, how can we minimize this infrastructure needed? And what we came up with was we need longer ranges, obviously. And so then we kind of, you know, that converged to hydrogen pretty quickly. And then, you know, we were looking, well, who has this kind of this vehicle that we want that meets Uber's requirements, that meets what the Air Force is trying to do. And while we're really impressed with some of the designs, like we love what Alakai is doing in Zero and Bartini, some of the other hydrogen aircraft, they're not a fixed wing aircraft. So this is a fixed wing aircraft. The wingspan is pretty small compared to some of the other ones. So it's got a low spotting factor. We're just really excited to announce her, and it's got a range of over 250 miles. And I probably didn't do Daryl's slide justice, but that's what he would have kind of talked about.
Daryl designed this aircraft with two things in mind. He wanted it to be viable for Uber Elevate, and he wanted it to be viable for U.S. Air Force.
Mm-hmm.
And in so doing, he created it in a way that it will be able to land in austere environments or on a rooftop somewhere. Either way, he designed it to be redundant and safe. So the fixed wing allows it to land conventionally if it's so needed. And the stacked rotor design is for redundancy. So in case of equipment failure, there will be some safe maneuvers that can be performed.
Yeah, for sure. I was just going to say, Daryl may be on mute. If he comes off mute, we might be able to hear from him.
I don't know. It's an ongoing kind of inside joke with us.
Yeah,
but,
we're just having a little technical difficulties
we are.
I think Daryl's internet is having some problems today.
He's with us in spirit, though, and we will hear from him soon. Okay, so with that, we can jump to Dr. Jacob.
Sure, and I'd just like to discuss that how we're going to be supporting H2O is primarily through a wide range of research design, testing and evaluation capabilities at Oklahoma State University Unmanned Systems Research Institute. So we've been focusing on a variety of different aerial mobility testing for the AAM market. So we have a wide array of expertise in manufacturing and flight testing composite-based UAS for nearly 25 years, ranging from small-scale Group 1 to Group 4 platforms for a wide variety of customers, including numerous teams within the DoD. So our expertise includes composite manufacturing, avionics, and systems integration, and you see a couple of our examples of our test facilities here. So next slide. This just shows another example of some of our systems that we have, but we have several flight test facilities that will be available for the program that allow us to test at different stages of the project, including the OSU Unmanned Aircraft Flight Station, which has runway and hangar facilities, as well as a beyond visual line of sight corridor. We are partners with the Choctaw Nation FAA UAS IPP test site in Southeast Oklahoma that covers over 45,000 acres and has hosted other AAM vehicles. And OSU also owns and operates a UAS test facility within restricted airspace at Fort Sill for government-only customers. And finally, our point of departure vehicle is going to be based around our BFD platform, which has a similar 8-rotor configuration to the Prism, allowing us to quickly demonstrate the flight control and dynamic systems of the proposed platform with minimal cost and time. Once this is demonstrated, we can easily scale up to larger platforms as program requirements mandate. Thank you, Danielle.
Thank you, Dr. Jacob. I don't know what we're like on time, but if we got that done in 10 minutes, I'm really proud of us.
Yeah, for sure. Thank you, Danielle. I just had a little bit of question on your STTR collaboration with OSU. Is the BVLOS drone hydrogen as well, or?
It can be.
Yeah, we currently have a hybrid system that's using both the fuel cell systems that are hydrogen based, as well as other hybrid technologies, so we can quickly adapt to that.
Sure, thank you. Well, I think unless there's any other questions from the Q&A, let me check. Yeah, so I have one from Bill Kleinbecker. Is OSU involved with the 5G early sites? Anything to talk about there?
Nothing that I can share at this time.
Okay. Well, thank you guys for your time today. I think we're going to switch over to Mr. Yancey from Hexel. We appreciate you guys coming on though. Robert, over to you.
Okay, good afternoon. Thanks to Colonel Dillard and the Agility Prime team for this opportunity. So I'll give you an overview of Hexel. We are the largest integrated composite material supplier in the world and supply extensively to the aerospace industry today, and are looking forward to provide our materials and support to this emerging ORV industry. So Hexel is, as I mentioned, we're an integrated material supplier. So we produce everything from the pan, precursor, carbon fiber, reinforcements, a variety of woven fabrics and prepregs, adhesives and resins, and a number of other capabilities, engineered products. And then we also have an activity in additive manufacturing that I'll explore. We also are the largest supplier of honeycomb core in the world. In terms of the US, we are headquartered in Stamford, Connecticut, and then a number of sites, and I'll go over those briefly. I am based in Salt Lake City, which is our largest operation in the US. In Salt Lake, we produce all of the carbon fiber and all of our aerospace prepreg materials. Going from left to right, so up in Washington State, we have engineered core facilities. This is a facility that helps shape the honeycomb core to the shape that you need it for your application. And then an engineered structures group just outside of Seattle that can produce all types of composite structures. We have our R&D facility in Northern California. We produce our honeycomb in Arizona. We produce our industrial prepregs, mostly for the wind energy market, in Colorado. We have full weaving and fabric capabilities in Seguin, Texas. We develop our pan precursor in Alabama. We also have another engineered core facility in Pennsylvania, headquarters in Connecticut, and then also our additive manufacturing operations are in Connecticut, and then a group up in Massachusetts that deals with RF and electromagnetically tuned materials. So when we look at the ORV industry, there are business requirements and customer requirements there. And so what we find is that this industry, they need higher build rates than the aviation industry does today. And it's starting to approach, if the industry fully develops, it'll start to approach automotive build rates. This industry needs lower material and processing costs, so they're looking for a lot of automation and faster processing methods. But they still need aerospace grade materials so that these vehicles are safe and reliable and can meet the certification requirements. The vehicles also need to be efficient. We talked about the different propulsion methods, electric, hydrogen, but all of those will need a lightweight structure in order to be most efficient. These structures need to be reliable, and composite materials are reliable material and have been used in the aviation industry for decades. But they also need to be cost effective and the ability to scale to the large volume production that is required. So let me just talk on some of the different technologies that we provide. So we are a large producer, the largest producer of aerospace grade carbon fiber in the world. So we kind of bucket these in three main categories. So high strength, lower cost fibers, we designate as our AS fibers. Then intermediate modulus fibers, those are primarily used for primary structure in aerospace today, designated with the IM designation. And then high modulus, which have very high tensile modulus, but a little bit lower strength generally. And those are used for a lot of satellite applications, space applications. All of these carbon fibers are produced, including the precursor in Alabama, and then the carbon fiber production in Salt Lake City. So, you know, we've been involved primarily in the aerospace industry, but have been quite involved in the automotive industry, especially for Formula One racing and those types of activities. So we've worked with the automotive industry for many years to be able to look at the kind of production volume rates that they're used to. You know, we've been very involved in aerospace. We understand the qualification, certification, and performance requirements for aerospace. And we have a very active technology R&T activity. And so what we see for the orb industry is really combining all of these, you know, the aerospace quality with the automotive rates, and having a robust research and technology focus to be able to develop the materials that are required for this industry. So if you look at composite materials today, they're primarily thermoset prepregs. So thermoset materials are, you know, it's a plastic resin that requires a temperature to set. And then once it's set permanently. And that's primarily what the aerospace industry uses today. But there's been a lot of interest in thermoplastic materials because they don't require the type of processing equipment you need for thermosets. There's more opportunity for automation and faster rates. And so we formed a partnership with a French materials chemical company, Arkema, a couple of years ago to develop really world-class thermoplastic prepregs. And so we're actively working on that, and we'll actually have a webinar next week on that topic with thermoplastics. So stay tuned for our continued efforts in thermoplastic. Our fibers have some unique advantages for thermoplastics. So our fibers, whether it's our thermoplastic or others, are generally the fibers that are used in these thermoplastic prepregs. But then, as mentioned, in our involvement with the automotive industry, we've developed a lot of more automated and faster processing materials. So we have materials that are well suited for automated placement machines, liquid composite molding, quick cure composites, out of autoclave composites, additive manufacturing, compression molding, pultrusion, thermoplastics, welding, and joining. We have all of those capabilities within Hexel. We also, as I mentioned, we're the largest producer of honeycomb, and one of the unique advantages we have with honeycomb is that we've developed honeycomb materials that are able to dampen the acoustic vibrations. And so our honeycomb materials are primarily used, or are the primary product used in engine nacelles because the honeycomb material dampens the noise coming from the engine, which is good for those that are outside the airplane, but also good for the passengers inside. And so we're actively working with our expertise in acoustic absorption materials to find ways to be able to lower the acoustic signatures of advanced air mobility. We know that that's a major issue that needs to be solved in order for these vehicles to be used widely in urban environments. I mentioned additive manufacturing. We produce additively manufactured parts in our Hartford, Connecticut facility. This uses an SLS process, selective laser sintering. It uses a high performance thermoplastic powder, PEC, that's provided to us by Arkema. And then we have it loaded with milled carbon fiber. And the milled carbon fiber provides some extra strength and stiffness to the material. It has some advantages in terms of electrical conductivity, and we solely provide these parts to the aerospace community. We have active partnerships with most of the aerospace OEMs, with the DoD. These materials are certified for flying and are flying on vehicles today, and are actively continuing to work on the developing the design allowables for the newest generation. So we have a current activity funded by the FAA to be able to further qualify and certify this material. So, and we do have customers today in the orb industry and look at this as an exciting technology, especially to replace metal castings or for very complicated geometries where the tooling costs could be prohibitive. And this is an easy way to be able to get those types of geometries produced in a lightweight fashion. There are some information on our website. I'll just point out some of the highlights. So we've been actively involved with General Atomics over the last few years on their UAV systems and have a published case study with them. Another news release that came out last year on being fully qualified for Boeing Commercial, and then have been in the press on a number of things. There's an interview on CNBC. So it's a qualified additively manufactured process that's in production and used for manned space, defense, and commercial aviation. So this is kind of a summary slide of what we look at, the different applications for composites in orb vehicles and the types of technologies that are applicable. So let me just kind of go through this list with you. So if you look at primary and secondary structures, they are generally stiffness driven and crashworthiness driven. And so thermosets are traditionally used there, but we've developed a lot of quick cure thermoset materials and out of autoclave materials so that the production rates can be satisfied. Generally, they use an intermediate or a high modulus fiber, and thermoplastics is also an emerging area of interest for that. If you look at the rotor blades, they need to be damage tolerant. Generally, there's braiding or fabrics that are used with intermediate modulus fibers, and then infusion resins are an effective way to be able to manufacture those blades at scale. If you look at frame structures, they're stiffness and strength driven, and pultrusion methods are excellent because they're low cost and can be produced in large volumes. If you look at the interior, they need quick cycle and reduced labor technology. We just recently introduced a new thermoset resin system that meets the flame, smoke, and toxicity requirements by the FAA, so are suitable to be used for interior systems. If you look at the brackets, ducting, complex shape components, additive manufacturing, or molding infusion processes are applicable there. In terms of parts manufacturing, that you need quick cycling, reduced labor, and tooling. So things like liquid composite molding, compression molding, infusion are appropriate there. And then for the engines, nacelles and ducting, using our honeycomb acoustic suppression materials apply. So there's a lot of similarities with the orb industry and the commercial aero industry, but rate and cost are key. And so, we continue to be actively involved in developing materials and processes to be able to meet the rate and cost requirements of the orb industry. So in summary, materials challenges for the orb industry is different solutions are available for different missions and different mechanical property specifications. So if it's an unmanned system, it has different requirements than a manned system. Hexel is a global leader in advanced composite technologies in aerospace and automotive. We have a wide breadth of material and engineered structure solutions for the orb industry. So we can provide the materials, we can provide the structures, we can help with the engineering, we can provide all of your composite materials structures needs. So we're happy to engage with any of you out there that are developing concepts and need a strong, trusted domestic partner to be able to provide your composite materials solutions. So here in summary, we've got some nice pieces on our website at the following locations, which kind of just discuss our view of materials challenges for both the unmanned aerial vehicle and the urban air mobility markets. We are doing a number of public webinars. And so we've completed webinars on simulation, the UAV, AAM materials issues, Prepreg 101, which is if you're new to composites, that's a great kind of primer to understand how prepregs are made. We've got a thermoplastic welding webinar next week, and then one's planned in the next 6 weeks on additive manufacturing, reinforcements, and honeycomb. So you can go to our website and sign up for upcoming webinars, but then you can also sign up and review the recorded webinars, and encourage you to go there. I've got my contact information here, so if anybody has any questions, feel free to reach out to me, and I'll put you in contact with the right individuals. So that's what I've got. Sterling, any questions I'm happy to address?
Yeah, for sure. Thank you for coming on, Robert. That was super informative. One question from one of our panelists, actually. Chris was wondering, are these types of composite materials RF neutral?
We can make them RF neutral. So we have this group up in Massachusetts that are really world experts in tuning the material for any dielectric or RF performance that you require. And we're just introducing a new material formulation with our additive manufacturing that significantly improves the conductivity of those materials for RF type of applications.
Perfect. Well, thank you, Robert. I think we're going to switch over to Larry Williams from ASR now, but thank you for coming on. We appreciate your time.
All right, good afternoon, Sterling. First of all, thank you very much for the opportunity to be here, and thanks to the Agility Prime team and Colonel Diller for their work in supporting the development of this exciting new market. Aviation Safety Resources is a company that designs, tests, and builds aircraft recovery systems that are designed to safely bring down an airplane in the event of an in-air emergency. These systems have been around for a long time, but we've taken the time to really look at the problem associated with vertical takeoff and vertical landing, specific to the advanced air mobility market. And we've developed a system that's specifically designed to work even with no forward speed. We call this our Extreme Rapid Deployment System. It features a very rapid deployment. It also will work at a very low altitude, and it will function quite well even if there is no forward speed to inflate the parachute canopy. So as everyone knows, there's over 300 different vehicle designs underway right now. Our system is designed to bring a level of safety to these vehicles and to give a means of recovery, especially in the VTOL environment. There's no other system out there today that'll work in that VTOL environment as efficiently. And we are also working with both unmanned systems as well as advanced aerial mobility and manned aircraft. Our products are also lighter weight. They have a lower cost and a lower operational cost with a repack cycle of 15 years that lowers the total cost of ownership over the life of the system. Our XRD system is the essential recovery system that's specifically designed to increase safety. And by increasing the safety, we feel that we can lower the design, the testing, and the operational cost, and ultimately lower the risk associated with these new vehicles. So we integrate various components that we've used for years, and we've applied commercial solutions along with brand new technology to help bring about a new type of vehicle recovery system and to give the operational flexibility that's needed in this urban air mobility or advanced air mobility market, in line with the Agility Prime objectives and what the DoD itself is looking for. We've got a team of people with over 40 years of experience of developing recovery systems And we've taken advantage of that experience to develop what we call the next generation of recovery. So there are parallels with what we're doing and what you see, for example, in automobiles and how airbags ended up really changing the injury mechanisms and the safety elements associated with automobiles. Airbags became mandatory about 1998, and the National Highway Traffic Safety Administration estimates that by 2015, there were almost 45,000 lives that have been saved with the use of that technology. Now, if we transfer that over and we look at aviation, and if you look at the baseline of the aviation accident rate for general aviation airplanes from 01 to 05, it was 7.97 accidents per 100,000 flight hours. And by 2016, there's a 57% decrease in that accident rate down to 3.45 accidents per 100,000 flight hours. Where this is relative, and what it means is that technology matters. Flying Magazine did an article a few years ago that said that in 10 years, there had been 42 parachute deployments on Cirrus aircraft with a 100% success rate and 92 lives saved. And incredibly, 1 out of every 110 systems that have been installed have been deployed. So we feel like aircraft designers need the solution that we bring to the table today. For example, we talked about automobile accidents. There's nearly 15,000 fatalities in automobile accidents across the country every year, but that's become socially acceptable. We accept that level of risk. But if you look at it, even just air taxi accidents, which averages only 18 fatalities a year, every accident makes national news, sometimes international news. So our solution is designed to help the market in advanced aerial mobility. We can't prevent the accident, but we may be able to prevent the fatality by giving another means or another level of safety if something goes wrong. And in the design, you could use the parachute recovery system as risk mitigation credit as you're designing the vehicle from a safety standpoint. Our concern is that if there were to be an accident in the early stages of development of the entire program, it could significantly delay the program completely. Look at the impact of the Virgin Galactic accident that occurred. Look at the impact to Uber on the self-driving cars and the accident in Arizona that killed a woman on a bicycle. And here more recently, the Kobe Bryant accident, of course, was worldwide coverage. So we feel like that we can offer a solution to this, an integrated solution that can be built into the design of the vehicle to give another solution or another outcome by allowing a parachute recovery system to safely bring down the vehicle in the event of an in-air emergency. Now, the way our system works is we use a retro rocket to slow the descent of the vehicle, and then we deploy multiple small parachutes, and we've calculated and figured out a way to inflate the parachutes on deployment. Therefore, we can deploy very, very rapidly. We can recover the vehicle in about 100 feet, and we can recover the vehicle in less than about 2.5 seconds. So technology really matters. Conventional recovery systems, they've been around for more than 4 decades. There's been more than 500 lives that have been saved with these systems, but they will only work effectively with forward speed to inflate the parachute canopy. If you don't have forward speed and you're in a vertical takeoff or a vertical landing configuration, the only way to inflate the canopy is with altitude loss. And this is not a capable solution in this environment. So what we've done is we've looked at this and we've specifically designed a system that utilizes advanced technology, advanced concepts to allow us to inflate the canopy during the extraction. And again, we can limit the altitude loss to less than 100 feet in about 2.5 seconds. So this is a very specific safety solution that the Air Force needs as defined in the Agility Prime program. So in summary, We feel like that we have advanced technology which will contribute to a mission need under this Agility Prime program. And by equipping these vehicles with this onboard safety system to mitigate the risk, it saves the assets, not only in the air, but also reduces the risk on the ground. We can accomplish this recovery and bring down that vehicle and its occupants where literally they can release their harness system and walk away. So we're a primary solution for the advanced air mobility market. We've established a relationship with Agility Prime, and we're looking for other vehicle OEMs that want to work with us to incorporate this important safety feature into part of their design. So with that, I'll close, and I'll be happy to answer any questions that may come up about our system and what we do.
Yeah, for sure, Larry. Thank you for your presentation. That was great. We have one question from the audience. They're just wondering about how much does the system weigh?
So one of the things that we set out to do in the early days was to make sure that our system was lightweight, and we're about 20% lighter than most of the other commercial systems that are out there. So if you took a typical airplane that say weighs around 3,500 pounds, then our system is it'll be less than 50 pounds at the current rate that we're seeing right now.
Sure, and then also just a little bit on the size of the system as well.
So weight is associated, directly connected with volume. One of the other things that we set out to do was reduce the volume, and we've actually had more positive results in reduction of the volume. We've had anywhere from a 30 to a 45% reduction in the volume than what traditional parachute recovery systems have. For example, we can fit the system for a 3,500 pound vehicle recovery system in an area that's about 14.5 inches by about 12 inches by about 11 inches in a cube in a box. Pretty small.
Wonderful. Well, thank you for coming on, Mr. Williams. We appreciate it. Very informative discussion. I think we're going to switch over to Tom Fury now. Mr. Fury, are you able to come on?
Yes, I am. Let me get my screen shared. Hi. Thank you, Sterling, and I'd like to thank Colonel Diller and the Agility Prime team for giving us the opportunity to participate in this exciting program. I'd like to introduce today's SageTech Avionics and talk a little bit about our company as well as our detect and avoid solutions and other airspace safety solutions. My background originally is flying A6 Intruder aircraft in the US Navy, and back then detect and avoid for us meant the Mark 1 Mod 0 eyeball. So it's very exciting to be part of technology evolution that will enable remote and autonomous flight using advanced systems. So our company is located in a place called the Columbia River Gorge outside of Portland along the Columbia River. This area in the 90s really started becoming a cottage industry for unmanned aircraft systems with the launch and then growth of In Situ, now a Boeing company, and many companies around the area give us the opportunity to share technologies and have a deep knowledge base of the people around there. Our focus as a company has been on low SWaP solutions for safe integrated airspace. It started in about 10 years ago when we were requested by a customer to see if we could shrink a transponder because carbon fiber and composite aircraft overseas in military zones were great because they were stealthy, but they were invisible to our own radar as well as enemies, and they were causing mid-air collision and safety issues with manned aircraft. Exactly the same situation we want to try and avoid in the future with autonomous systems. So we've become experts in aviation surveillance products, yet we're committed to very reliable and compliant solutions. The solution that I referred to that we started about 10 years ago, 9 years ago actually, the XP transponder, there are multiple versions of that. It has evolved slightly over time, but it has become a basically standard equipment for almost all military UAS. It's the size, if you look at the picture on top, you can't quite tell the size. A life-size picture of the product fits on the back of my business card, and it weighs about 1/4 of a pound. It's very robust, and it also meets the highest design standards. We have a version of it that is certified by the Department of Defense Ames office, which is the Department of Defense Transponder Certification Office. It remains flying not only in military aircraft, but we've had it flying above 100,000 feet in balloons. It flies in experimental aircraft, and it continues to this day to be a robust product. A few years ago, we recognized that needs of industry were evolving for autonomy, and as well as certification as rules were being written. So we created the MX platform. So the picture you see right there is two MXs. The MX itself is the size of a deck of cards and weighs about 1/3 of a pound. But the platform is super robust and very powerful. It's got a lot of processing power in it. It's got diversity antennas for its RF transmissions for, and reception for surveillance equipment. And it is capable of doing multiple different functions. Right now, we're finishing the certification of the MX-12B, which is a military IFF version. So that's Mode 5 IFF, and this will be in a couple of months when this launches and completes its certification, it'll be the smallest Mode 5 solution available to military UAS, which is important because Mode 5, as of July 1st of 2020, is required on all NATO aircraft. We also have a civil version of a transponder that is in the late stages of FAA certification. Again, diversity, which provides dual antennas, which enables it to be seen through area and satellite ADS-B systems, as well as avoid any aircraft shadowing issues, both for transmission as well as reception of transponder and ADS-B signals. We have a third version of this, which is sort of the inverse. It's a whisper shout interrogator that can interrogate other aircraft transponders. That combination of capability in a single platform makes it ideal to create a full detect and avoid solution for UAS, for UAM, and for AAM aircraft. Detect and avoid, this looks crowded, and it is because airspace can get crowded. So picture yourself in that UAM aircraft that's roughly in the center of this. You will need to get type certified and to be safe in airspace. You'll need to have a system that enables you to avoid collisions with any different aircraft that can be in your airspace. And there's a few different types of aircraft that you can run into. There are, if you look in the upper left, and then about the 6 o'clock position, there are aircraft that are going to be equipped with similar, either TCAS, traffic collision avoidance systems, or ACAS, airborne collision avoidance systems. Those are going to be commercial aircraft and potentially large and medium-sized unmanned aircraft. A DAA system will not only recognize those aircraft, but also communicate with them to provide cooperative collision avoidance. One aircraft would be commanded to climb, the other would be commanded to descend to make sure they don't collide. If you look at the 8 o'clock position, a typically what's called a cooperative aircraft out there that'll have a Mode C or S transponder, generally with ADS-B out, will provide the DAA system with means of identifying the aircraft, its location, but it won't be able to coordinate with an ACAS system. So the ACAS system will then need to provide well clear instructions to the pilot or the remote pilot or the system in the case of an autonomous system. And then finally, you'll have other aircraft like the lower right that don't have a transponder, that are considered non-cooperative, and you'll need a radar system to give you well clear guidance to make sure that you don't crash into that aircraft since you can't communicate. As a side note, in the very lower left, small drones under the UTM system right now are required by the FAA under the Notice of Proposed Rulemaking to remain well clear of manned aircraft while they determine how UTM and typical air traffic management systems will relate to each other. So our MX platform is perfectly positioned to enable us to create a very, very low swap solution integrated with a few other components that provides the ability to detect and avoid all those different types of traffic that we described in the previous slide. So on the left-hand side, in the dark gray box in the center, you see a group of functions. You've got ADS-B receiver information, identifying what aircraft, cooperative aircraft are out there. You've got active surveillance, then interrogating those aircraft to validate their ADS-B, because ADS-B by itself is not a detect and avoid solution. Not all aircraft provide ADS-B information. That ADS-B information could be wrong or it could be spoofed. So you need to have active surveillance to validate that information. That, along with air-to-air radar providing uncooperative traffic. You can see that on the right-hand side going into what's called the surveillance module on the top. That fuses all those tracks of the censored, the sensed aircraft. So now you have a common picture of the traffic around you. And as any get into any bubbles that require some sort of avoidance maneuver or coordination, that's the threat resolution module on the bottom. All of those boxes there can be contained in one MX platform box to provide all those features, like I said, in a 1/3 pound box. Working as a full DAA solution, we'll be bringing in standard off-the-shelf small radars as that technology continues to evolve. You need to have a certified command and control link. And then finally, the ground control components of that, the other side of the command and control link, and presenting traffic to and providing controls for a remote pilot. So all of that in that bigger, lighter gray box is a full DAA solution that essentially can be an MX platform as well as an air-to-air radar and software that goes into that. And then you can see surrounding it, you have attitude information that comes from an outside system in the aircraft. You have the flight control system, obviously, that's outside of the DAA solution, but needs to coordinate with it. And then you have a separate certified transponder that for threat resolution will help communicate with other ACAS or TCAS equipped aircraft. So we're very excited to progress along a super low swap complete DAA solution, because for UAM, for AAM, and for all UAS, reducing size, weight, and power obviously is important for the size of the aircraft, the weight and the thrust requirements and the battery requirements on eVTOL. So really excited to introduce everybody to SageTech. Love to work with Orb OEMs to find out their specific requirements and how they're trying to solve the problem for DAA and how we can help, as well as anybody that needs to reach out to talk about transponder solutions and particularly Mode 5 military transponder solutions. So are there any questions that I can answer via the chat box?
Yeah, thanks, Tom. That was great. What kind of interfaces do you have to the C2 links, Ethernet, USB, serial, etc.?
Right now, we're working on the ACAS portion of that, so we haven't designed C2 link, and we're either going to work with off-the-shelf C2 links as they exist or create those. Our communication protocols for our transponder and all of the MX features are through Ethernet, RS-232, and RS-422 serial.
Thanks. And then we have one more question here. Does the system architecture allow the ability to integrate existing ground-based radar info into certifiable DAA?
That is something we may include. We're still working on this solution right now. So we have the components of it created. So if that's a need, and that is something that we can absolutely attempt to put into the architecture. That would be through the C-Link and communication, probably through the C2 link and communication back into the surveillance module.
Yeah, for sure. All right, I think that's all the questions I'm seeing. So thank you for coming on, Tom. I appreciate it. It's very informative. We're glad to have you. I think now we're going to switch over to Scott Bledsoe with Blue Force Technologies. Scott, do you still want me to share for you?
Yeah, if you don't mind, thanks.
Sure. Just 1 second. Let me find it for you.
Thanks, Sterling. I appreciate that.
For sure. Let me get it a few in here. Is that showing all right?
That shows just fine. Yep. So my name is Scott Bledsoe. Sean Herman was originally going to be the speaker for this activity. He's our VP of Future Projects, but he had to run out on urgent business. And so I'm taking over. I'd like to say that if I knew I was going to be on the internet talking to a whole bunch of people, I would have worn a better shirt. So apologize for my dress code, but I thought it was going to be just an easy Friday. But if you have questions for us in the future, don't hesitate to reach out to Sean. His contact info is there. And so I'd like to thank the AFWERX team for putting this together, and definitely like to thank Dr. Roper and Colonel Diller for the vision to put an audacious program like Orb together. We're happy to be a part of it in a small way, and happy to have the opportunity to talk. Next slide, please. So Blue Force, at our heart, we are a aerostructures company with a composites emphasis. We love helping companies accelerate their programs by building large structural assemblies for them. On top of that, we've added over the last few years aircraft design capabilities. We actually do full configuration design work and aerodynamics. We've got both an external aero capability as well as propulsion flow path design for high-speed vehicles. And so currently, we're actually on 3 SBIRs with AFRL, either as a prime or a sub, on everything from electric VTOL aircraft all the way up to helping a company lay out propulsion flow path for a Mach 5 vehicle. So we like to say we cover the entire Mach range from 0 to 5. We've been in business 10 years. In that time, we've completed 75 unique projects or more than that for 45 customers. Our headcount's about 80, including about 20 engineers. We're still growing as an essential defense business. We've been able to keep it together through COVID and actually add a few people this year. So very fortunate for that. Back in the good times, there were over 1,000 aircraft flying our parts. I'm sure with the airliners being grounded, that takes that count down, but we've delivered thousands of instances of flightworthy structure through those 10 years. Including 2 commercial space OEMs that are engaged in the space tourism business, rely on us for primary structure. So one of the things we've developed internally, we do a lot of work on one-off rapid prototyping for people, and we've developed a fully digital advanced rapid prototyping system. I'll talk more about that in a minute, and I'll give project examples where we've applied that. And as well, on the production side, we do sort of the tried and true pre-preg production programs as well, including being Boeing Supplier of the Year in 2018 for the work we do on the Chinook, where we were 100% on time and 100% quality for about a 5-year stretch. So really, at the end of the day, what we buy our customers or what we sell to our customers is a 2 to 3 year time advantage on getting their product to market. We can do both the rapid prototyping and pivot into production with them. Next, please. So an example of this that I think is pretty familiar to the Agility Prime crew is Beta Technologies, and we're proud to be on their team as their structures partner. Early on with Beta, they wanted to go out and demonstrate and learn about the technologies associated with electric vertical takeoff. And so on the left side of the screen, you see a Lancer 4 that they converted to basically an eVTOL with stacked rotors. They wanted to learn about that configuration. So we did a rapid build using our infusion technology on the outriggers that hold the rotors, and then also the cowling for the extended nose, and did that over the course of just a couple of months, including a full spin on design and analysis. On the right side, obviously as a team, we learned a lot of things from the Ava vehicle and pivoted to the Alea vehicle, which has gone public in the last 2 months. So many of you may have seen the articles and seen the pictures that are here. It is a 50-foot wingspan vehicle, about a 6,000-pound takeoff weight. And again, we were the sole structures provider on that, and we leveraged our infusion technology. We kind of took it to a whole new level and basically reached the point where we can deliver on soft tooling, which is the easiest kind of tooling to make. Normally, there's a lot of sacrifices like that involved with using soft tooling, but we can deliver near prepreg properties on soft tooling, and the only hit we take is on service temperature. And then more recently, we've actually attacked the service temperature issue. Next slide, please. Another earlier design build activity for us was Darpa Aries. This was pretty early in our company history, and we were working for Piasecki, which is a rotorcraft company in Philadelphia. They're definitely a VTOL pioneer, going back to the early days of the helicopter, and the prime on the program was Lockheed Martin. So we had design build responsibility on the ducts. This is a ducted propeller configuration. You see those ducts are about an 8-foot diameter. So we had design build responsibility on those and the control surface downstream of the duct, as well as doing build to print work on the outer wing panel and the high temperature skins for the center wing panel. So a lot of structural content on this vehicle. The challenge here was being a ducted rotor configuration with a wing on the outboard side. It was really first of its kind. And in forward flight, the wing bending loads want to ovalize the duct, and the propeller is always a circular arc, so you got to keep those two apart. So we were having to manage the clearance between the duct and the prop through a lot of structural tailoring. And at the same time, this was a one-off rapid build program, so we couldn't go to the most exotic materials out there. So it was a trade-off between tooling and manufacturing techniques and what we could achieve stress-wise and stiffness-wise. And so, yeah, another good example. If you go to the next slide. More on the production side of things. So I mentioned the Chinook earlier, and we've actually been in production for about 6 years with the Chinook. We've delivered over 285 ship sets and basically ran that as a turnkey program for Boeing. So we build both the aft landing gear access door, and then more recently, we've pivoted into the entire top deck of the vehicle. It's called the tunnel covers. And so this is an example of where we helped Boeing early on develop an out of autoclave process that was equivalent to their previous autoclave process. And then we were able to pivot into production with Boeing. So very, very proud to be on the Chinook team. And then likewise on the LEAP engine, there is a set of composite structure that's a very light gauge composite carbon fiber skin with honeycomb core that we machine those in production. And I think 2 years ago, we did over 800 ship sets. Obviously this year, with airliner business being what it is, we've come down in our volumes, but very proud to be on their team as well. Next slide. So coming back to kind of the defense world, another couple of programs that we've helped enable on the Kratos XQ-58A Valkyrie. They came to us. We were, I believe, one of the first companies that they had ever subbed composite structure out to. They were highly vertically integrated, but reached the point in their success curve where they needed some help. They came to us. We did a manufacturing engineering and tooling and build project where we built a significant part of the tooling, probably 60–70% of the tooling for that vehicle. And we also built internal structure for it, maybe about 40–50% of the internal structure. The bottom left of the screen, also Kratos was on a team with Dynetics on the Gremlins program, built a lot of tooling for those guys. On the right side, this is an example of an FAA certified primary structural application. We're teamed with Sierra Nevada. They have a nose extension that they put on the King Air. It was a metallic solution that had a pretty high part count, pretty high labor time associated with it. We came in 2015 and helped them design a much lower part count, more highly integrated, and I think a better looking piece of structure that was composite, and really helped reduce the amount of time required for them to put a nose modification on the aircraft. We went through STC with them, did all the heavy lifting on the stress analysis side, and worked with their DERs, and as a team got that completed at the end of 2018. Next slide. So I think we're coming to the end. I just wanted to paint the example or paint a picture with a bunch of examples, but here are some more. So we're a key structure supplier to Virgin Galactic and the spaceship company. We build the majority of the structure in the feather structure at the aft of Spaceship Two, as well as building some key structure for Blue Origin on their various products. And on the bottom left side, we've built all composite cryogenic tanks for liquid hydrogen. So I should definitely reach out to the folks earlier who were talking about hydrogen powered vehicles. We have lightweight tank solutions there. We're building landing gear doors for the Stratolaunch aircraft. And normally you might say landing gear doors was the big deal. It's the world's biggest airplane, so it has like 64 landing gear doors. So it's kept us busy for quite a while. And so, yeah, I think that's a good overview of what we do. If you go to the next slide. So yeah, and so I'd like to wrap up by saying thanks again to the Agility Prime crew. We are, happy to be a key teammate for anybody out there who's got a program coming to fruition, and happy to be a part of your success. And I'd take any questions you might have.
Yeah, sure. Thanks, Scott. Let me just look and see if any questions came in. No, none so far. So I think we'll leave it there and switch over to Chris. I appreciate you coming on. That was very informative and great to see all the work you guys are doing.
Thank you.
Chris, last but not least.
All right, let me go ahead and share that slideshow and swap between screens. All right, does that look good?
Yeah, we got you.
All right, fantastic. So thanks everybody. This is a great analogy for building an aircraft. Typically the last thing that anybody thinks about when building an aircraft is their communication system, so it's very fitting that I take the last spot as we move forward. Chris Wallauer, sales engineer with Persistent Systems. I could talk about this particular subject for several days, so I hope you guys all are ready for that. No, luckily for you guys, I got 10 minutes. So what I'd like to do is focus a little bit on the technology and then get through it so that if there are any questions, we can walk through that. What do we provide? We provide a network data link. So we are a MANA network, a mobile ad hoc network, meaning that our devices talk to each other, all right? So everything in the network is just like everything else. So this is not like a mesh system, which is something like your cell phone would be. So if I want to call you on the cell phone, my phone doesn't talk to yours, it talks to a cell phone tower, which then talks to a distribution center, which then talks to another tower, which then talks to you. So lots of single points of failure. So that's not necessarily good, particularly when you're talking about safety and security and things like that. So in those cell phone networks, the more nodes that you put around those cell phone towers, the worse the coverage gets. Whereas with a MANA network, the more nodes in the network that you have, the better the coverage you'll have, the more potential pathways you'll have, and the better the entire network will perform. We're also using multiple input, multiple output for our RF, which is called MIMO. This is actually great for an urban environment. We're utilizing bounces and skips and things like that in traditional RF are bad, but for us it actually improves our connectivity. And to emphasize that point, our headquarters is actually off of 5th Avenue in downtown Manhattan. And our CEO constantly says, if you can make your RF work here, you can make your RF work anywhere. The other thing is that we are data agnostic. So we don't really care what data that you're pushing across. We're just going to send it all layer 2, make sure the data gets to where it needs to go. And we're talking about voice, video, location data, C2 data, telemetry sensor, anything and everything that you could potentially provide. One of the other things to note on that is it's not voice or video, video or location, it's and. We are providing a large tunnel pathway in the multiple megabytes where you can pass all of these things over that same pipe. One of the other things that makes us very unique is that we're built from the ground up for mobility. So Wave Relay, that is our patented routing mechanism, and that is actually how we transfer information through the network. Traditional mechanisms are built for the internet, for fixed site, for routers that sit in buildings, computers that sit in your office, and things like that, whereas ours is actually built from the standpoint that everything in the network is going to move constantly. So we do things in a much different way and really love when things are moving around. We find the most intelligent pathway through those complex, complicated moving networks real time and automatically so that the end users don't have to do anything. And then of course we can hop between them. So even if I don't have direct line of sight to a particular user where I need to pass data, if I can see someone else who can see someone else who can see that person, it can jump through the network to get to where it needs to go. One of the other things is scalability. So traditionally, particularly at the early stages when we talk about aircraft, it's normally point to point. We're going to fly one, we're going to fly one UAS, we're going to fly one VTOL, and we're going to check out and see how it does. But in reality, when we start looking at what's going to happen down the line is these are going to be part of a larger battlefield network infrastructure, or they're going to be part of a citywide infrastructure on the civilian side. So you need to start thinking about it's not going to be one-to-one, it's going to be many-to-many, right? We've done all sorts of scaling testing with a lot of our DoD partners. The biggest one that we've done is a 320 node test. This was incredibly difficult because all 320 nodes were on a 1 square kilometer by 1 square kilometer patch of dirt, which means that every single node in that network could see every single other node. So each one was talking to 319 other nodes. We had guys passing video, we had guys talking voice, we had dudes kicking in doors, we had other guys doing video teleconferencing over it, and it performed fantastic. We've built not citywide infrastructure, but we've built base-wide infrastructures for the military before, our largest of which is 1,900 square miles of coverage. All right, if we go ahead and take a look at the product lineup, I've pared this down for Agility Prime, so 3 basic things to talk about. One is the MPU-5. That is the actual radio itself. That's the device. We use one platform for handheld vehicles, aircraft, UAV, UGVs, maritime, and anything and everything in between. We actually have a smaller version, a stripped down version, the embedded module for small UAS, but for this particular VTOL, we'll stick here. We have the ability to swap out RF cards for different frequency bands to include L band, S band, lower and upper C band. We have an integrated video encoder system. So if you have an MPU-5 in there passing your data, you can actually plug your camera directly into the MPU-5 and it can encode and decode that information for you as well. We also have on each device an onboard Android operating system. That operating system can be used to install, safety algorithms, AI algorithms, things like that. We've actually, we're in the middle of testing right now with Autonodyne, putting their autonomous flight software onto the MPU-5. We have worked with facial recognition partners before, audio recognition partners before, and so we can really leverage that to do all sorts of very unique and interesting things, all within the same swap of that device. We also have radio over IP or ROIP, so we can tie in other line of sight radio systems into the MPU-5 so that its audio can come through the MPU-5 system. We've done this with SATCOM systems, we've done this with commercial aircraft systems, with military radios, civilian radios, and everything in between. The next one is our integrated sector antennas. So these are essentially the MPU-5 guts shoved into a sector antenna. It kind of looks like something you put on a cell tower, giving us 120 degree of area coverage and really boosting up power and things like that. This is the antenna that we utilize on a lot of our base-wide infrastructures. They're very simple installations. We've got a power block at the bottom. It runs one Ethernet cable up with PoE and you're good to go. The final one is our tracking antenna. Right now we are limited to 130 miles in our distance for communications, but we have tested with our tracking antenna and maintain not only location data and voice data, but also full motion video at that 130-mile range. All right, moving along, talking about it from an Agility Prime standpoint. So there's really three areas to talk about: aircraft integration, coverage, and then compatibility with other networks. So aircraft integration, this is something that we've been doing for years. The picture up there is actually a King Air. That's one of our antennas on there, flying up at 30,000 feet. We've also been integrated with the Beta team. I know Scott just talked about that in his discussion. So not only are they flying the Blue Force technology parts, but they're also flying MPU-5s for their network communication. We have several different antenna options, and then we also help out with installation consultation as well. We have the sector antennas for blanket coverages. Again, if we start talking about citywide networks for safety, for communication, for any of those types of things, we've got that covered. And then we work closely with cellular networks. AT&T is one of our big partners that we work with. So we can actually tie into a 3G or 5G network. And then one of the interesting things about how a wave relay works with finding the best pathway out is if we're connected to another network, that network has a better pathway. It can intelligently follow that route, go through the 5G network. Then if you get out of the service area, or if something happens like a natural disaster or something like that, and the cellular network goes away, it will automatically, with no downtime, switch back over to the RF and you'll be good to go. This next slide is the most complicated slide I have ever made in my life. It's just a bunch of logos. The whole point here is to emphasize that in the aircraft industry, we work with a whole lot of partners. Some of these are not just business partners of ours, but ones like In Situ and Raytheon and those types of companies are actually part of our ecosystem, where you can purchase UASs or aircraft with MPU-5s already installed in them from the factory. I've noticed that we've got some questions coming in, so I'll pause here, let you guys look at that, and then open it up to questions.
Yeah, for sure, Chris. Actually, I think we're going to have to end at 3:30 as we have another meeting on the channel. But could you provide your email link for the folks asking questions, and they can reach out to you directly?
Yeah, absolutely. I'm going to stop sharing, and then in the chat, I will go ahead and put my email address. And then if you guys had a question, you can follow me up there.
Yeah, so to all the speakers, thank you so much for joining us today. We really appreciate it. Doing very similar stuff next week with some more folks from the ecosystem. So join us again then. Thank you guys all. I'll give you time there, Chris.
Oh, there we go. Just sent it up. Panelists and attendees, it should have gone to. So please let me know.
Yep. Thank you guys, everyone. Have a good rest of your day and rest of your weekend. Appreciate you.